Here we are in Algebra 2 at Trig, 6A.1. We're going to graph exponential growth and decay functions. An asymptote is a line that a graph approaches. And it gets closer and closer to that line. That's called the asymptote, but it never touches it. In an equation written in the a, b to the x format, that's either growth or decay. We don't know the value of b, but the asymptote is still going to be the x-axis, called y equals 0. So we're going to take a look at graphing y equals 2 to the x. There's a couple different ways we could do this. We could think about a table. You can pretty much pick any x values you want. You want to do negative 1, 0, 1, 2, and 3. 2 to the 0 power. Anything to the 0 power is 1. Two to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. We're going up by a multiple of 2 every time. So our b value is 2. And as we keep coming back, the negative 1 is your x, so that's going to make a fraction out of the 2, which is 1 over 2, which is our fraction 1 over 2. So our y-intercept is at 1 because that's our a value. You could just go straight to the graph. You know your a value is 1. And then you're going to multiply all the current y values by 2. So 1 by 2 is going to give you 2. And then 2 times 2 is going to give you 4. And then 4 times 2 would be up here at 8. As we come down the other direction, at negative 1, that means we're taking half every time as we come in backwards. So we'd be at a half, we'd be at a fourth, we'd be at an eighth. So you see that the points are approaching the x-axis, but will never actually touch the x-axis. We have an asymptote at the x-axis, which is y equals 0. So we want to label that on our graph. Put the dashed line, put the equation of your asymptote. We know we have our horizontal line at y equals 0. We have a domain. Domain are your x values. Look at your graph. Look at all the x values. Negative 1, negative 2, negative 3, even at 0, and 1, and 2, and even 3, and so forth. So it's any of the numbers. It's all real numbers. You can plug in any number you want to. What answers can you get? Well, I got the number of 8 way up high. I got the number of 4 and 2 and 1 and a half. I could calculate halves of those all the way down. What answers are possible? What is the range of the function? The y value is going to be greater than 0. It's not going to be equal to 0. You can never touch the x-axis. But it's going to be greater than 0. Interval notation, we'd still have to have a curved bracket because you cannot touch the 0. And of course, you're never going to touch infinity. It's not a location. So for your interval notation, that would be 0, infinity. For all real numbers, interval notation would be negative infinity till positive infinity, both with curved brackets. End behavior. Haven't done that in a while. as x approaches the left, as x goes to negative infinity. Take a look at your graph. As x goes further to the left, where is the graph going? Okay, it is going down forever. You're always taking half in this case, moving to the left. But it's not going to really go towards negative infinity. It's never going to hit a negative number. So it's not even going to hit 0, but it's going to get closer to 0 every time. So it approaches 0. As x moves to the right, as x gets bigger, we notice that the values get bigger pretty quick. And there's no limit to the number that they can get. So we would say that they are approaching infinity. In the comparison, there's no reflection. There's no stretch. Some people think the stretch is going to be the 2. But the stretch is your a value, and the a value is a 1 in this case. And of course, there's no translation. So the last thing we need to do is write our equation, y equals 2 to the x power, on our graph. So notice that my graph has dots and the equation, the asymptote and its equation for the detail. Our next one. For a table set of values, we typically want to look at one that's at least negative. We definitely need the 0, and we need to look at a value that's positive. All depending on the numbers, you can get creative on just what those negative numbers are. But what we're going to look at is when x is 0, this is 4 to the 0, which is always 1. So negative 1/2 times 1 is negative 1/2. So we're down here at negative 1/2. When x is 1, 4 to the first power is 4. Take half of that 4 is negative 2. And then over here, you would take the reciprocal of the 4. So it's 1 over 4. And when you times that to the fraction, you get 1 times 1 to make 1. You get the 2 times the 4 to make an 8. And the fraction is negative, so it's negative 1 over 8. So that means at negative 1 would be here at 1/8 that distance to the x-axis. So we never reach the x-axis, but it is curving downwards. This is the equation. Negative 1/2 times 4 to the x power. We have an asymptote at y equals 0. So here we say y equals 0. The domain, of course, is all real numbers. Your range is less than 0. You would call that negative infinity up to 0 with rounded brackets on both of them. For your end behavior, as x looks to the left, the graph is approaching 0. And as the graph moves to the right, the graph is going farther down to negative infinity. In terms of our comparison or our transformations, we see a negative. Reflected over x-axis. We have the half, which is a vertical shrink by factor 1/2. There is no translation yet. We don't have a number next to the x or a number after the whole function. We don't have an h or a k. Now, when we look at this one, you can really tell by looking at the equation, you see that the a value is less than 0. So right there, this is not exponential decay. This is not exponential growth. It looks like exponential growth because the b value is greater than 1. But because the a value is less than 1, we have reflected over y equals 0. This is not growth or decay. It kind of looks like decay because it's declining forever. But it doesn't fall underneath the category of growth either. So it is just exponential. Number 3. Probably use the numbers 0, 1, or -1, 0, and 1. When you plug in 0 for the x, you get 1/4 times 1/4 to the 0 is a value of 1. So 2 times 1 is 2. So at 0, we're up at 2. 1/4 to the first power gives us 2 times 1/4, which is 2 times 1, so 2 over 4, which is 1/2. So that's the fourth. 1/4 of 2 is a quarter. And then the reciprocal of 1/4, the -1, is a value of 4. So 4 times 2 is 8. It's not -8. It would be a +8. So at -1, we're up 1, 2, 3, 4, 5, 6, 7, 8. So that's our equation, 2 times 1/4 to the x power. We know we have our vertical asymptote here at y equals 0. That's not vertical, I'm sorry. A horizontal asymptote at y equals 0. We have our domain, which is all real numbers, because you can plug in any x value you want into your equation. The answers you're going to get are going to be greater than 0. As x approaches -infinity, the y value approaches +infinity. As x approaches the positive direction, the y moves down towards 0. There is no reflection. But we have a vertical stretch by a factor of 2. We have a vertical stretch by a factor of 2. It is not translated at all, so we don't have to talk about that. Now we have a couple examples where we're going to talk about the translations. Okay, we've done H's and K's before. So we're first going to graph A times B to the x power. Then we're going to translate the graph horizontally H units and vertically K units. We'll have a horizontal asymptote at y equals k. So we're going to start out our first example by graphing 2 times 4 to the x power. That is not 8 to the x power. You cannot do that. You can either make a table, or you can just use your values, which the a value is your y-intercept. So watch your scale. You're up at 2. Then now we're going to multiply all the y values by your b value. So 2 times 4 is 8. And 8 times 4 is 32. So it would be pretty high at that point. So then we'd come down, it would be 1/4 of that, which is at 1/2. So you can see that your graph is coming downwards and approaching the x-axis. So that's y equals 2, 4 to the x power. Then we're going to take every one of our points. We're going to translate it horizontally h units. We know our h value is going to be -1 because our equation is x plus 1. And our k value is going to be 3. And it's actually a -3. So we're going to go to the left 1 and down 3. 1, 2, 3. Watch your scale. To the left 1 and down 3. So we're down here, trying to figure out where we are. This is y equals -3 as our asymptote. So the graph is going to proceed downwards all the way to approaching -3. We translated the graph 1 left and 3 down. So our asymptote was at -3 with a domain of all real numbers and a range that was greater than -3. We always start end behavior out as x equals. And we notice that this is approaching -3. It's going down. It actually goes down forever, but it never will reach -3. As we move to the right, we notice that the graph is increasing to infinity. In our comparison, we know that there is no reflection, but we have a vertical stretch by a factor of 2. And we're translated 1 unit left, 3 units down. in our graph up here, it would be good if we would write our equation as 2 for x plus 1 minus 3. Write your equation. Label your graph. So we'll move down to our next example, which is y equals negative 2, 3 over 5 to the x power. So you can make a table out of this, or you can use this area to do your calculations. When x is 0, we know we're going to be at our a value, so we're at negative 2. When x equals, let's put it right here, when x equals 1, we're going to be negative 2 times 3 over 5. So that's going to be negative 6 over 5. That's negative 1 and a teeny bit. At positive 2, we're going to have our fraction that is squared, so it's going to be 9 over 25. So when we multiply, we get negative 18 over 25. 12.5 over 25 would be a half, so it's a little bit past a half, but it's still less than 1. Then over here, when we test it, we already know what 0 is. When we test it at negative 1, that means you take your negative 2 and you flip your fraction over. With a negative exponent, you flip your fraction over, and it's negative 10 over 3, which is negative 3 over 3. Which is 3 1/3. So we know our graph is coming through, it's curving, and it starts to come down. So this is going to be y equals negative 2, 3 over 5, x. We're going to translate this graph. Our h equals 1 and our k equals 1. So we're going to go left 1 unit. We're going to go up 1 unit. Of course. We're going to go right. Let's try that one. We're going to go right 1 unit because it's x minus 1. The formula is x minus h. So if h is a positive, it's not going to affect the negative at all. So it's still going to be x minus your h value, which is x minus 1. So it's moving to the right because the h is 1. So we're going to take each one of these points and go 1 to the right and 1 up. 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 So we'll label our graph y equals negative 2, 3 over 5, x minus 1 plus 1. So because we went up 1, we know we're going to have a horizontal asymptote at y equals 1. So we're going to have it at y equals 1. Our domain is all real numbers. Our range is less than 1. Our end behavior as x approaches the left direction, negative infinity. The graph is going downwards. As x approaches the positive direction, the graph approaches 1. We do have a reflection over the x-axis. We do have a vertical stretch by a factor of 2, and we are translated 1 unit right and 1 unit up. We do have a third page. Just more examples. So this third page is one for you to try. So you go ahead and try this one. I'll pause the video, I'll do the problem, I'll show you what we've got, and you compare yours to mine. So for my graph, I first graphed out -2, 3 to the x power, and then I translated all those points. Two to the right, and 2 up. So I have a asymptote at y equals 2, a domain of all real numbers, a range that is less than 2. So this right here is going to tell us this is not exponential decay, this is not exponential growth. So our end behavior, as x approaches negative infinity, the graph is going to approach 2. And as we move to the right, the graph is moving way down to negative infinity. We have a reflection over the x-axis. We have a vertical stretch of factor 2, and we are translated 2 units right and 2 units up. Okay, you've got one more here. Pause the video again, give it a try, see how you're doing, come back and figure it out. Now to graph out this one, it does get a little trickier because of our b value. Well, we know that when x is 0, we're going to be at our a value. And then when we look where x is 1, we're going to be 3 times 2/3. That's 6/3, which is 2. When we're at 2, we're going to be 3 times the square of this, which is 4/9, which is 4/3, which is 1 and a little bit. And we'll do one last one if you like. So we're 3, and we would cube the 2 to get 8, and we'd cube to get 27. So this is 24/27. So that's a little bit less than 1. And when we try -1, you would take the reciprocal. So that would be 9/2, which is 4.5. 1, 2, 3, 4.5. So we have our graph of 3 times 2/3 to the x power. Then we're going to take all of those and translate it 1 unit left and 3 units down. 1 unit left, 1, 2, 3. 1 left. So we have our equation y equals 3 to the 2/3 x plus 1 minus 3. We'll have our horizontal asymptote at y equals our k value, which is -3. Y equals -3. Our domain is all real numbers. Our range is greater than our k value. As x moves to the left, the graph is going up. And as x moves to the right, it's getting closer and closer to -3. We do not have a reflection. We have a vertical stretch by a factor of 3. We are translated 1 unit left and 3 units down.